The digital revolution has been one of the most transformative periods in human history. Computers have become ubiquitous, changing the way we work, play, and interact with the world around us. But even as the industry matures, there's a new frontier just beyond our grasp. One that promises to unlock incredible new possibilities in medicine, materials, science, artificial intelligence, cryptography, and more. This is the frontier of quantum computing, a field that has the potential to change everything from the way we design new drugs to the way we keep our data safe online. At its core, quantum computing harnesses the bizarre rules of quantum mechanics to perform calculations in ways that are impossible for even the most powerful classical computers. By harnessing the power of quantum entanglement and superposition, these machines can explore multiple solutions to complex problems simultaneously, opening up new frontiers in fields as diverse as medicine, materials, science, and artificial intelligence. While this technology is still in its early stages of development, it holds tremendous promise for the future. In today's video, we will take a deep dive into the world of quantum computing, exploring what it is, how it works, and the potential impact it could have on our world. So sit back and get ready to learn about the next big thing in computing. What is quantum computing? At its most basic level, quantum computing is a type of computing that harnesses the power of quantum mechanics to perform calculations in ways that are impossible for classical computers. Unlike their classical counterparts, quantum computers use quantum bits or qubits to store and process information. Qubits can exist in a state of superposition, meaning they can represent both 0 and 1 at the same time. This allows quantum computers to explore many possible solutions to a problem simultaneously, making them exponentially faster than classical computers for certain tasks. One of the key features of quantum computing is the ability to perform operations on qubits that exploit quantum entanglement. Entanglement is a unique quantum phenomenon in which two or more qubits become linked together in such a way that they share the same fate, regardless of the distance between them. By manipulating entangled qubits, quantum computers can perform calculations that would be impossible on a classical computer because of the vast amount of data that would need to be processed. Quantum computers are still in the early stages of development, but they have the potential to revolutionize a wide range of industries. For example, in medicine, quantum computers could be used to develop new drugs and therapies by simulating the behavior of molecules and cells. In materials science, they could help researchers develop new materials with specific properties. And in artificial intelligence, they could enable the development of new algorithms that can learn from data much more quickly than traditional methods. How does quantum computing work? Quantum computing harnesses the power of quantum mechanics, which governs the behavior of matter at the atomic and subatomic level. At this level, things behave very differently than they do in the macroscopic world that we're familiar with. One of the key features of quantum mechanics is that particles like electrons can exist in a state of superposition, meaning they can be in multiple states at once. This is unlike classical bits, which can only be in one state at any given time. To understand how this works, let's take a closer look at the building blocks of quantum computers. Qubits. Qubits are the quantum equivalent of bits, the basic unit of information in a classical computer. However, while a classical bit can be either 0 or 1, a qubit can be in a superposition of both states simultaneously. This is because quantum objects like electrons can exist in multiple states at once until they are measured. Once they are measured, however, they collapse to a single state, either 0 or 1. Another important concept in quantum computing is entanglement. Entanglement occurs when two or more qubits become linked together in such a way that they share the same fate, regardless of the distance between them. If one qubit is in a particular state, then the entangled qubit will also be in that state, even if it is light years away. This interconnectedness allows quantum computers to perform calculations in ways that are impossible on classical computers. The power of quantum computing comes from the fact that these machines can exploit superposition and entanglement to perform calculations on vast amounts of data simultaneously. This means that they can explore many possible solutions to a problem at once, making them exponentially faster than classical computers for certain tasks. However, it's important to note that quantum computers are not a replacement for classical computers. They are simply specialized machines that are particularly well suited for certain types of calculations. The challenges of quantum computing. While the potential benefits of quantum computing are immense, there are also significant challenges that must be overcome before this technology can be widely adopted. One of the biggest challenges is maintaining the delicate quantum states of qubits. Qubits are extremely fragile and can be easily disrupted by environmental noise, which can cause errors in calculations. Another challenge is the difficulty of programming quantum computers. Because qubits are so fragile, it's difficult to write programs that can execute on quantum hardware without introducing errors. Additionally, the algorithms used for quantum computing are still in the early stages of development, and it can be challenging to determine the best way to exploit the unique features of quantum computers to solve real-world problems. Despite these challenges, researchers are making significant progress toward developing practical quantum computing applications. For example, IBM has developed a quantum computing system that can run algorithms written in a high-level programming language. Google has also demonstrated the ability to run a quantum algorithm on a large enough scale to outperform a classical supercomputer. The potential impact of quantum computing as quantum computing technology continues to develop. It has the potential to impact a wide range of industries. In medicine, quantum computers could be used to develop new drugs and therapies by simulating the behavior of molecules and cells. This could lead to the development of new treatments for diseases like cancer and Alzheimer's. In materials science, quantum computers could help researchers develop new materials with specific properties, such as increased strength or conductivity. This could lead to the development of new materials for use in solar cells, batteries, and other technologies. Another area where quantum computing could have a major impact is artificial intelligence. Quantum computers could be used to develop new AI algorithms that can learn from data much more quickly than traditional methods. This could lead to the development of new AI systems that are much more efficient and effective at performing tasks like image recognition and natural language processing. Quantum computing also has the potential to impact fields as diverse as finance, logistics, and environmental science. For example, quantum computers could be used to develop new financial models that take into account a wider range of factors, leading to more accurate predictions and better investment strategies. They could also be used to develop new logistics systems that optimize transportation routes and reduce waste, or to develop new models for predicting climate change and mitigating its effects. Conclusion: the rise of quantum computing marks a new frontier in the world of technology, one that holds immense potential for the future. By harnessing the bizarre rules of quantum mechanics, quantum computers can perform calculations in ways that were previously unimaginable, opening up new possibilities in fields as diverse as medicine, materials science, and artificial intelligence. While there are still significant challenges to overcome before this technology can be widely adopted, the progress that researchers are making is nothing short of astonishing. As quantum computers become more powerful and easier to program, we can expect to see new applications emerge that we are not yet able to imagine. The race is on to develop the most powerful quantum computer and the first practical applications of this technology. And as the competition heats up, we can be sure that the pace of innovation will only accelerate. What are your thoughts on the future of quantum computing? Do you see it as a revolutionary technology that will change the world, or as a distant possibility that will never be fully realized? Let us know in the comments below. Thank you for watching. If you enjoyed this video, please hit the like button and subscribe for more videos.